All right, so this is Learning Target 5.1, question 1 and 2. I got some requests from period 7 that they would like to have some of these questions answered with the video. So here it is. All right, so we have negative 81 inside the cube root. And so we need to find 3 of a kind, 3 of the same identical base that we can multiply to get negative 81. So it looks like it's going to be, let's see, 81 can be broken down by 9 times 9. But because it's negative, I'm going to make one of those negative and the other positive. In order for me to have one negative 9, I need to have one negative 3 and one positive 3. I'm going to switch the direction on this one because it'll be easier for me to group later. And then this one, even though it's positive, I'm going to make its factors negative 3. Then we have a group, one group of negative 3s and 1 3 left behind. So that would take the 2 that's already outside as the coefficient of the radical. And then I would have negative 3 be multiplied with 2. And the remaining variables will remain in the radical with the 3 that I have left over from here. This one matches this one. And then a to the 9th power and b to the 2nd power. Okay, so a to the 9th power can be broken up with a to the 6th power and a to the 3rd power. And then that one's going to be a to the 3rd and a to the 3rd, meaning this one, let's see if I could write it all out. This a to the 3rd power, each one of these make a group of 3 a's. So I have 1, 2, 3 a's come out and play. So we have negative 6 a to the 3rd power. And then what's left behind in the cube root is going to be, I'm going to move this down so we can see it better. Hold on one second. Oops, let's try that again. I'm going to have to just shrink it. All right, so if I shrink it, that gives me a little more room. And then this is going to be 3. And then I'm left with b to the 2nd power because there's no group of 3 that we can make with b to the 2nd power. So this is going to be your solution or simplified expression for question 1. Okay. Question 2. Question 2, we have 300. So let's break that down into 3 and 100. 100 can be broken down to 10 times 10. And since there's nothing here, which means we're looking for square root. The nth root is going to be the 2nd. So we have 2 of base 10 and 3 left behind. So I have 10 square root of 3, and then m to the 4th power and n to the 25th power is going to be left behind. And then let's break down m to the 4th. I have 2m to the 2nd power and m to the 2nd power. Now, if I could keep breaking it down and get m times m and m times m. That would show me that I have 2 groups of m squared. Sorry, 2 groups of m's, a pair of m's. So one of these would become m out here, and another one would be the other m. So that still ends up being m squared. I hope that makes sense. So this is going to be 10 is going to stay as it is. M squared comes out because I have 2 groups of it. And then I have square root of 3n to the 25th power. Okay, so n to the 25th, I can break this down into multiples of 2 and then whatever I have left over. So 25 can break into n to the 24th power and then n to the 1st power. Then I can see a little easier that I would have two identical groups of 12 ends. So I can pull out this number of ends, 12 groups of ends. So I have 10 m to the second power and n to the 12th power. Then I would have, let me change that color to purple, n to the 12th power. And then the remaining pieces inside the square root would be 3n. That should be how we end up with that expression. Now, I got a really good question earlier. Why can't we just break that into n to the 5th times n to the 5th? Because 5 times 5 is 25, right? But if you do that, you're breaking that power rule of adding the exponents. You should be adding these two exponents because it's the base are the same. And this n to the 5th power means n times n times n times n times n. And then this second one is going to be also n times n times n times n. And I don't have any more space, so n. And that gives me total of 10 n's, not 25. So this equals to n to the 10th power, not n to the 25th power. So you can't use this method at all. This will be a no-go. You have to break it into something that you can add up to 25, like 1 and 24, to break it into the correct number of n's being multiplied, okay? So do not use this method, please. Okay, so I'll erase that. And that's it for 1 and 2. Next part will be question 3 through 5. And then I will go ahead and answer question 6 on a different video. On the study guide, anything at all. Cooper. Number 3 is what was asked. Okay, number 3, 4, and 5. It would benefit you the most if you treated it with power rules of exponents or exponent rules of powers, whichever way you want to say it, instead of taking it into radical form first. Okay? So if I have two powers that are being multiplied, what do I do with the exponents? Add them. So what I would do is take this 4 and negative 6/5 and add them together on the side. Okay? To add a fraction with the whole number, I need to change the whole number to have the same base as the fraction, same denominator as the fraction. So what do I need to multiply 4 by? 5 over 5, right? 5 over 5 is what I need to multiply 4 over 1. And I should get 20 over 5 plus negative 6 over 5. So 20 plus, or 20 minus 6 is what? I hope I didn't hear 12. I think I heard 14, right?
That was not me, that was
It's okay. It didn't get recorded because you guys are too far from here. It's okay. 14. So it's going to save that same base. Okay, we do not multiply the base because we are just simply stating how many 7s we're multiplying together, all together, right? So 7 stays the same. Base is always the same. Then we're going to write in our new exponent of 14 over 5. I'll write it in red. Okay? This 14 over 5 tells me that the index of our index of our radical is going to be 5. So it's going to be 5th root of 7 to the 14th power. One more time?
There is a negative sign with it.
No more, because I had 20 plus negative 6. Right? Okay, so we have 5th root of 7 to the 14th power. Okay? How many groups of 5 can I make with 14 7s being multiplied? 2. Where did the 2 come from? I have 7 to the 10th power and 7 to the 4th power. If I add those two, do I get 14? So if I break this 7 to the 10th power into 2 equal groups of 5, then that would be what I can pull out to simplify it. You want to say it again? Okay, so if I have one group of 7 to the 5th power and one group of 7 to the 5th power, right? I have 7 times 7 times 7 times 7, 5 sevens here, and 7 times 7 times 7 times 7 times 7 here. So how many groups of 5 am I pulling out there? 2. So I'm going to put out 7 to the 2nd power because there's 2 of these. Does that make sense? Okay. So I have 7 to the 2nd power equals to 5th root of 7 to the 4th power. I can't quite make 5 with the 4 that I have left, so they stay behind. Okay? If you get to this and you box it, I will consider that correct, and that's sufficient. Okay? If you want to change 7 to the 2nd power to 49 and put 49 5th root of 7 to the 4th power, that's fine too. And if you do want to go a little further and say 49 5th root of 2,401, I think that was it. That's fine too. Does anyone need me to tell you how I got 2401? You know how I got it, right? I hope. Okay. Questions? Yeah.
So if we just left it like the first box, would that be okay, or do you simplify it more?
What did you hear?
Yeah.
Yeah. Yep.
Wait, how come it's going
7 squared instead of 7 to the 5th power? How many groups of 5 am I making here? 2 of them, that's why. I have one group of 5, that would come out as 1 7, right? And then another group of 5 would come out as another 7. So 7 times 7 is 49. 7 squared, right? Okay, anyone else?
Can you please go over number 5?
Number 5, got it. Number 4 too? Okay, number 5 and then 4, or 4 and then 5? Which one? 4, then 5? Chloe, is that okay with you?
Yeah.
Okay, so 4, here we go. What's the base to this 3? Exponent of 3. Nope. The entire thing in the parentheses. Okay? The entire thing in the parentheses is going to be the base to this 3 as an exponent. Okay? Which means if I were to write it out, if I were to expand it, it would look like 11k to the 4 ninths times the quantity of 11, not really quantity, sorry, 11k to the 4 ninths times 11k to the 4 ninths and 11k to the 4 ninths. Agreed? Does that make sense? Bases multiplied 3 times. 1, 2, 3. I multiplied it 3 times. How many 11s are we multiplying all together? 3 of them. So it's 11 to the 3rd power. And k to the 4 ninths, how many of them do I have?
3.
So I can say I just multiplied that by 3. Agreed? Okay, then if I were to not write this and jump right to this, the last line I wrote, can I just say it's 11 to the 1st power times 3? And 4 ninths times 3? It's the same thing. Power of powers is multiplying the exponents together. Okay? We don't add, we multiply the exponents together. So I have 11 to the 3rd power stays as it is, but this 4 over 9 times 3, what can I do to multiply those two? 4 over 9 times 3 over 1. What do I do?
The cross multiply.
No.
Kidding.
Do not cross multiply. Cross simplify? Yes. Cross multiply? No. So 3 over 9 becomes 1 over 3. Agreed? Yes? Cross simplify, cross simplify is the only thing I can come up with.
Or butter.
No. There's nothing buttery about this. Or flying. It will not fly with me. Do not say it. Okay, here we go. So this is same as 4 over 3. Do you agree? Okay, so it's k to the 4/3 power. Okay, now, is this 3 in the denominator for the k to the 4/3 power? Is that 3 for cube root of k only or 11 and k? It's only for k. 11 has an exponent of whole number 3. Does not have any denominators in that exponent, right? So 11 to the 3rd power should stay out of the radical sign. Okay? Then we have 3 as our index for the radical. And k to the 4th power is what remains. Can I simplify that again? Okay, I have 4 k's being multiplied. K times k times k times k. How many groups of 3 can I make? 1 group of 3. So how many k's are walking out of there? Only 1. So I have 11 to the 3rd power. K. And then what I'm left with inside the cube root is just 1k. Okay? Any questions on this one before we move on?
That one, what I did was I did this, and then I didn't get the same answer.
Why do you have 9 for the whole thing? It's not 3 over 9. If that was the case, then yes, you can do it this way. But the 9th root
But
is
don't you
only
do-
for k.
Don't you do this one first?
9th
and then-
root is only for k, not 11.
Oh. Oh yeah, because you have to have the parentheses.
Mm-hmm.
Can you keep that up?
Yep. Yeah.
On question 5, I don't understand why you multiply 8x by x to the power of 5.
Okay, I'll go over number 5 in a second. Is everybody okay with question 4? No other questions on 4? Yes. The fraction. So do you remember that, I think it was the 3rd lesson in this unit, where I said, if you have x to the 3/5 power, that denominator is now the nth index of our root. So it becomes 5th root of x to the 3rd power. Then what? Oh, simplifying fractions. Okay, so that's 4 over 3 times 3 is same thing as 9, right? Yeah? And then 3 times 1 over 1. So I can simplify 3 over 3. Then I have 3 left over of the 9 and 1 left over of the 3. Why are you looking at me like? I did it too fast. Yeah? I did it too fast or it's confusing? Which one? I just factored it so you could see it better. You okay? Huh? It's already uploaded. I did it last night. The recording will be up tonight. Okay? All right, anyone else? Are we okay? Can I move on? Number 5? All right, number 5, here we go. Do you want me to do one for each problem?
Yes.
And then do you want me to separate it out by problem, or is it okay if I just make it into one big video? That's so much to upload. I'll think about it. It depends on how much time I have tonight. Okay, 8x to the 1st power divided by x to the -5th power. Now, there's 2 ways to go about it. The rule for dividing exponential powers is that you take the numerator's exponent and take the denominator's exponent of the same base and you subtract them. Do you remember that? It was a long time ago back in middle school. Boys, stop touching. Okay? So we take this 1 and -5 and you can subtract them. Okay? So if I subtract 1 minus -5, what do I get? 1 plus 5, which is 6. So you can rewrite this. Does 8 get affected by that negative 5? Nope. So 8 comes down as it is, or stays as it is, sorry. It should all be in the numerator now, because x to the 6th power is a positive value, and that's where it ends up. That's one way. Here's another, okay? So 8x over x to the negative 5th power, right? Okay, here's another way. Remember, I told you, whenever you guys have a a negative exponent, you can take the reciprocal, right? So if I take the reciprocal of x to the negative 5th power, this is same thing as saying 1 over x to the 5th power. Agreed? And when you divide a fraction, what do we do? This is last unit, come on. Keep the first one, and then we divide by 1 over x to the 5th. What do we do now? We flip this, right? And where does the x to the 5th end up? On top. So this would become 8x times x to the 5th power. Yes? What's happening? Okay, let me go back a little bit, okay? Take the reciprocal of x to the negative 5th power, okay? What's the reciprocal of that? 1 over x to the 5th, okay? This is, overall, if you look at it as a whole, this is the same thing as saying 8x divided by 1 over x to the 5th. Agreed? No. That fraction bar also means divide. Do you agree? So if I were to replace this fraction bar, the blue one that's underneath the 8x, with the division sign, then I would write it out as 8x divided by 1 over x to the 5th. Yes? And when we divide any numbers with fraction, we do keep it, change it, flip it. Keep, change, flip. Yes? Keep the 8x, change the division to multiplication, and flip this, and I get x to the 5th power. Are we there now? Okay. Then we have 8x times x to the 5th. So how many x's are we multiplying altogether there? 6. Isn't that the same thing? So it's 8x to the 6th power. Okay? I just went really long way about it. I told you if it's a negative in the numerator, you dump it. If it's negative in the denominator, bump it. And if they're positives, we keep it where they are. Right? Keep it, bump it, dump it. Yes? How are we doing? Any questions?
For
Yeah.
the test, are we allowed to use our index card without any documentation?
Correct. But if you have a copied version of your study guide pasted onto the index card I gave you, you're out of luck because I'm going to take it away. Okay? Yeah. Yes, absolutely. If you want to copy number for number, line by line of the study guide right onto your index card, 100% fine. You want to use my answer key to do that? Totally fine. Don't print it out and paste it on there. Okay? Don't be lazy about it. What's up? Nothing. Okay. Yep, Sasha. Nope. Anyone else on any part of this? Is there any other problems you want me to work out for sure for the video? All right, question 6. Question 6, I'm looking at this and I could do multiple things, but I think it would be easiest if I automatically recognize that 9 can be simplified with square root. So square root of 9 is going to be 3. And then square root of x to the 5th power is going to give me, see, x to the 5th is same as x times x times x times x times x. So I can make one group of 2 and 2 groups of 2. So I have x squared be simplified out, leaving me with one single x left behind in the radical. Okay, then I have 36x to the third power. And I still have some people who are having trouble with breaking these down. So I'm going to break 36 down to the factors using 3 because I have a 3 in the numerator. I can simplify with 3 that are factors of 36. So 3 times 12 is equivalent to 36. So there's the 2 factors. And then 3 times 1 is going to be equivalent to 3. And then the x squared will remain as it is. Square root of 3 will remain. And denominator also has x times x times x because that's x cubed, right? While I'm at it, I'll go ahead and write out the x squared as x times x. Okay, I hope that helps so far in terms of people who are having trouble with simplifying. So here's my giant 1 of 3. And then I'm left with 1 over 12. Okay, so that's 1 over 12. And then x over x over x becomes 1. And then square root of 3 stays as it is, and x is left behind. So if I were to simplify that, it would look like this. Square root of 3 over 12x. Okay, and that's the first x. All right, question number 7. Rationalize the following radical expressions. So all 4 of these have to do with different ways to rationalize any fractions with radicals in the denominator. See, all 3 of them, or all 4 of them, have radicals in some way in the denominator. There's 2 ways to go about it. You can simplify the radicals in the denominator first and then multiply by a whole 1 equivalent of that denominator's radical part, okay? Or you can just take it as it is and multiply by the whole 1 equivalent of the radical that's already given. I like simplifying because that would mean that I have smaller numbers to multiply, and you would still end up with the same result as you would use this exact same radical denominator it as an equivalent of 1, okay? So I can take square root of 20 over square root of 20, or I can break it down to 4 times 5 and rewrite it as 2 rad 5 because the 2 came from 4, like so, over 3, okay? So I'll do both ways. I'll do it where we keep it as square root of 20 first, and then I'll work it all the way out, and I'll show you how it ends up being the exact same as if we were to use this format after we simplify the denominator, okay? So first part, so that 3 and then multiplied with square root of 20, we're going to leave it exactly as it is because we need to treat the radical expressions just like we would treat a variable. Okay, so square root of 20 times square root of 20 is going to come under the same house, and it becomes square root of 400, which ends up being same as 20. Okay, then we have 3 rad 20, and that rad 20 can be simplified with 4 times 5, and 4 has 2 identical factors of 2, and then I'll be left with 5. So if I did that, 2 can come out and multiply with 3, and then 5 would be left behind in the square root. So it'd be 3 times 2, which is 6, rad 5. Okay, and then 20 would remain as it is. And I don't know if you noticed, but if I were to leave it factored like this for the 3 times 2, I can also leave 20 factored as 2 times 10. When I do that, I can make a giant 1 using 2 over 2. Then I'm left with 3 rad 5 over 10. Okay. Like I said, I'm going to show you how if I were to multiply by 2 rad 5, rad 5 over rad 5 with what's given here, I should be able to end up with the same solution as this one, 3 rad 5 over 10. So let's try it out. Let's see, green. I'm going to multiply numerator and denominator by just the radical piece of the denominator, which is rad 5 over rad 5. Then the numerator is going to be 3 square root of 5 over 2 times square root of 5 times 5. And square root of 5 times 5 ends up being just 5. That would simplify as 5. So 2 times 5 is going to be 10. And then 3 rad 5. See? Exactly the same. Okay? So it doesn't matter which way you go about it. If it is easier for you to not simplify first the denominator and then just use it as square root of 20 over square root of 20, totally fine, because at the end you should end up in the same place if you did it correctly. Okay? All right, question 8. Question 8, we are multiplying by the denominator of square root of 8 and square root of 8. Again, you could factor this and simplify to 2 rad 8. They're the same, so you should end up with the exact same result as me leaving it as square root of 8. Okay? So when you do this, you're going to be distributing square root of 8 to square root of 5 and to 3 square root of 6. Then we have square root of 5 times 8, which is going to be square root of 40. And then square root of 8 times 3 square root of 6 is going to be 3 square root of 6 times 8. Oops, I should have written that here. I'm going to move it back. That should be here. Okay, let me shrink it just a teensy bit. Okay, and then zooming in, this should be plus equal. Then this would be 3 times square root of 48. Okay, this is going to be all over square root of 8 times 8, which is 64. So square root of 64 is 8. Okay, now I'm going to simplify the 40 by factoring and seeing who we can pull out as a square root. So we have 4 times 10. 4 has 2 times 2, so there's my group of 2, and then 10 is left over. So here it is. So it should look like 2 rad 10 plus, this one's gonna be 3 times rad 48. 48 is broken down into 4 times 12, and 12 has a 4 as well, so I have 3, and 4 can come out since it makes a perfect pair there, perfect square. So we already have 3. I'm taking my 4 and simplifying it. 4 times 4, square root of 4 times 4 is 16. 4 times 4 is 16, so square root of 16 is 4. And then I have remaining pieces right here, 3. So that one stays inside the square root sign of 3. Then we're going to take that and then over 8. So we have 2 rad 10 plus 12 rad 3 over 8. This solution I would consider a 9-pointer. Okay, if you factored the even numbered coefficients here, the 2 and the 12, so I can simplify with the 8, that would take you to a 9.5. Okay, so that would be 2 times the quantity of rad 10 plus 6 rad 3. And then put that over 8, which is 2 times 4. 8 is the same as 2 times 4. I wrote it out as factors, so we can do this. 2 and 2, 2 over 2 simplifies as 1, so I'm left with 4 in the denominator. So the solution is going to be rad 10, square root of 10, plus 6, square root of 3, over 4. And that's it. Okay? And if you use square root, I wrote that wrong, didn't I? This is supposed to be 2 rad 2, not 2 rad 8. Okay? So if I take 2 square root of 2, I should be able to use this as an equivalent like that. So it would look like 2 rad 2 over 2. Sorry, let me do that again. It should be rad 2 over rad 2 that I'm multiplying for numerator and denominator. And I should be able to factor anything I need to factor out, or it'll take me simplified just to this solution, okay? So that's 7 and 8. This is number 9, question 9 for learning target 5.1. So let's get started on here. Let me start with this color. So we have 5 over 3 plus rad 7. So this is what is happening here. I need to take my original problem, and because the square root of 7 is locked in place with the plus sign, I have to multiply by its conjugate. The conjugate is not an opposite. It is simply a number that we can multiply with that will result in a whole number. So it's going to be 3 minus rad 7. That's the conjugate to 3 plus rad 7. So I'm going to make that into a whole 1 by writing exactly the same thing, numerator and denominator. Treat this like a quantity, okay, because it is. And then we would have 5 times the quantity of 3 minus rad 7 over, now this one's a little trickier. We have 3 plus rad 7 times the quantity of 3 minus rad 7. Okay. Numerator is pretty easy to multiply because all you have to do is distribute. Okay. So that 5 times 3 becomes 15. And then minus 5 becomes a coefficient to the radical, 7. Okay. Over. This part right here needs to be done using the area model. Area model is our quick way for us to multiply binomial by binomial, or binomial by trinomial, or trinomial by trinomial. It may be any kind of polynomial being multiplied together, and it would make your life so much easier because there would be less mistakes happening within these. Okay, so I have -7. No, not yet. Sorry. I should be multiplying by 3 minus rad 7, and I'm going to change this to 3 plus rad 7. So the black part, I'm going to go ahead and match that up. So this is that part, and then that yellow is going to be right there. Okay, so if I multiply these two, 3 times 3 is 9. And then 3 times rad 7 is 3 rad 7. And then negative rad 7 times 3 is going to be -3 rad 7. And then the last one will be negative. Square root of 7 times 7 is 49. So square root of 49 is still 7. So it would be -7. Now it looks like we have a pair of 3 rad 7s that are opposites. And then we have a pair of 9 minus 7. Those are the constants, so that should work. So then this denominator will become 9 minus 7, which is 2. And then we're going to have -3 rad 7 right here. -3 rad 7 plus 3 rad 7, and that actually equals to 0. So 2 plus 0 is going to be still 2. So I believe this part is done, because even though we can factor out 15 and 5, there's nothing in the denominator that will allow me to simplify with the 5. Okay, so I believe this is done as it is.